If you have just taken your first tentative steps in the strange realm of the C programming language and have already acquired something which has a lot in common with self-confidence, then well, be prepared that there's already the next strangeness lurking around the corner. But if you familiarize yourself with such encounters, they may quickly become gifted with a new tool for your programmer's everyday life. And one of that weirdnesses I will talk you through today. Welcome to myCTalkthroughs. Somehow talking about it feels like trading your everyday clothes for a straitjacket. Recently, I was tinkering with a small tutorial C program that was supposed to explain the quicksort algorithm, and I encountered one of these oddities. Strange, odd, weird, kind of bizarre at the first glance. So, here is the little program I was demonstrating quicksort with. It's kind of very simple. I have here my program in the function main, an array of 100,000 ints, and that I fill after I initialize some random generator here with random numbers between 1 and a million. So after creation of that array, I sort it with quicksort here, and just to show you how it is working, I will let it run now. Obviously here's a little mistake, and here we go. So you see here 100,000 elements are created, they are sorted, done, and all that within fractions of a second. Allow me here some side note about random number generation. Imagine random numbers in a computer like a library with an infinite number of books. All these books have an infinite number of random numbers in it. And if you need a bunch of random numbers, you can take just one of that books from the shelf and open it and read one random number after another. But in this analogy, whenever you take exactly the same book from the shelf, you will therefore get exactly the same random numbers. So you need to make sure that your choice of random wisdom is different with every time you run your program, and that you can achieve with the function srand here. And srand provides some kind of a seed, a number which needs to change with every run of the program. And with srand you make sure that every time you run your program, you take a different random number book from the shelf by handling over time here as an argument. So much about random, respectively pseudo-random numbers in your computers. Now we turn here back to the quicksort function, and if you see here, I will run it just again. It is really unbelievable fast, but surprising, really surprising here is line 26, and there it is quicksort function's fourth argument here. It is the name of the function that compares values. That is here below at line 37, the function compare. The function itself just compares two values after you handed over a pointer to a pointer or something, or you handed over a pointer to a value and this here returns a value after comparing that two values at that spot in your memory. And yeah, that is not what causes confusion here, or which may cause confusion here. Surprising is how and what exactly is handed over to quicksort as an argument here. Look again here at line 26. The identifier here, compare, is the name of the compare function. From line 36 respectively, here at the line 7 you see the declaration of that function. That compares two values. But note, it is the name of the function and not the function call, and therefore not the return value from that function, what is handled over as an argument to quicksort. So let that sink in. From one moment to the next, you suddenly find yourself stumbling like Alice in Wonderland deep into the rabbit hole, even without any white rabbit hurrying you. So, if mentioning the compare identifier is not a function call here, and it is aiming not to get a return value, what kind of value do we pass over here, and how does that whole thing work at all? Yeah, a quote from the Joker, impersonated by the unforgettable Heath Ledger, is willing to provide a path to a solution. Madness, as you know, is like gravity. All it takes is a little push. So let's take that as a prompt to follow up. Like a variable in the C language, a function here, like this, has an address, a location in memory where the function resides. This shouldn't be surprising to you. After all, the function has to live somewhere. And as I know, that location doesn't change as the program runs. A function's address is an attribute used as an argument in several C language functions. You may have seen this requirement in the C library functions already, but didn't realize it. And so it works here in our call to quicksort, or of quicksort. Look at the quicksort statement. When a function is used as an argument, the parentheses are absent. That means it is not a function call and not returning anything. With the parenthesis, the function is called and does whatever it does, and then may return some value or not. But what you see here now is something different. Without parenthesis, the function's address is returned. Yeah, and to prove that claim, I prepared a little code snippet here that I will copy in and show you the difference. So what we have here now is we have a function called function, and that returns an integer. It returns in any case the 23. So, and now we have here two printf statements. One uses function with parentheses. So this is a function call which will return us a 23. So the output here will be the value of the function is 23. But look at the second statement. Here the address of the function is returned because there is no parenthesis. So have a look. We run that, and as you see, The value of the function is 23, the address is, and here follows a hexadecimal number. So this may now appear to you some kind of normal and leaves you shrugging your shoulders and skip to a video where a woman on a futuristic motorcycle is doing a wheelie with a yodeling giraffe as a co-rider. When I learned about this thing here, I felt for some time like Johnny Depp in Fear and Loathing in Las Vegas, recovering from a trip before preparing for the next level of reaching, in quotation marks, higher consciousness. Obviously, the address shown here in my terminal will be different from the one you see if you try this code. And maybe also the format here of this address will be different in some way. But the point is that without parentheses, the compiler reads a function's name as a memory location, a pointer. Function identifiers are kind of variables, and under the hood these variables are pointers. Hence, function names are pointers to addresses in your memory and can be used as those. As a pointer, a function also sports a variable type, which makes sense. And if you have to get it really weird, you can save a function's address in a pointer variable and even use that variable then to call the function. But that is too much madness for just one lecture. Remember, we are just returning from Las Vegas, so that's a different story and shall be told a different time.